of 0.00000000172 ohms. That's a bit of an awkward number to remember or to use in any of our equations. So what will you be using for copper is 1.7210 to the minus 8. Now, I'll come back to that in a sec. That is the fixed constant for copper. Yeah. Does anybody else remember what your material we use mainly for wiring, carbon copper?
Is it tin?
Gold.
Not tin, the actual
Oh, right.
Gold.
Aluminium?
Gold.
Yeah.
We have aluminium cables as well, and they start from 16mm up to any smaller than that. They're too brittle. We don't use them in house wiring. But bigger cables, industrial size, they use aluminium cables. That has also got a fixed constant, and that fixed constant is 0.0000000 1, 2, 3, 4, 5, 6, 7, 265 ohms per millimetre cubed, or, and I'll write this on there, copper 1.72 10 to the minus 8. Yeah. Aluminium 2.65 10 to the minus 8. Can you write that down, guys, just for the two? That's the only two we'll be using, because those are the two cables we use. There's other type of materials we use. I ain't worried about that. Steel, and we're not going to bother about that. And I don't think you'll ever get questions about that either. We'll see that.
Yeah, well, I can't really see that. Can you read that out again, please?
Martin, it's sort of blurry on my screen, you know. Like, it's proper blurry.
That's your screen.
No, it's not. I'm telling you, it's not.
Is that any better?
No, it's just frozen.
It's not only for me, then, if it's for everyone, then how's it going to only be me?
No, because some people have the internet settings. Can anybody see that? Read that clearly.
No,
No,
it's blurry.
Jack, can you see?
It's all, it's all
it's
blurred.
just I can't see the writing.
Can you see the writing?
No.
Not really.
Who just
Uh,
guessed?
Is that any better? If I stay out of the way, is that okay now?
It might.
Nah.
Yeah.
Any
Right.
better?
I'll,
The problem I've got with this is when I use Teams, when I move closer to the camera, it blurs out the background, which is a bit of a pain. It doesn't stay focused on one set thing. It tries to follow the movement.
I can't see nothing, you know, I'll be honest with you, like nothing.
Are you on your computer at home?
I'm on my iPad.
How big's your iPad screen?
It's quite big, you know.
But you can't see that screen. You can't see that wall.
No, not at all.
I can't either, and I'm on my
I'll
computer.
take a screenshot and I send it to you, Martin. If you think you don't believe me.
No, I can believe you. That's what it says. There's a few teething issues with this, but I can't. This is the best I can do. Let me try another way. I'll turn that off.
Yeah, now I can just see a black screen now.
Well, Martin, where you gone?
I'm just having you in the room, mate. Can you see that screen now? Can you good? Better?
That's even worse.
That is worse. How about that?
Martin, you're having an hour, mate.
Guys,
You can just about see it.
you can just about see that screen.
When you get closer, it gets proper blur and you can't see anything.
And that's what I mean. When I get
Well,
close,
Whoa.
close me.
Use that
So
one.
what I'll try and do is stay out of screenshot so he doesn't keep following me.
Alright.
A second. And you'll see me popping in and out of screen picture. We'll move things across.
Do you want us to write down all of what you've put on the board?
No, because it's in the book. I'm going to put it on the board like I normally do. Just so.
Martin, I can't see your hair.
Can you see now?
Just about.
So, Martin, everything you write down on the board,
Sure.
can you say it out loud? then we can try and do it that way instead. Just have to listen instead. But
Okay. I won't do too much on the board then. I'll just try and talk you through it. I'll stand you, let's stand in front of the class.
Yeah.
Right. Resistivity. Basically, every material we've got has got a fixed constant, which means it's got a certain resistance level. The more... You okay with that, guys? Can you hear me all right?
yeah,
Yeah. What page are you?
Yeah.
So, just making sure. What is with this? Resistivity is a fixed constant for copper. A fixed constant for aluminium as well. These are set in stone. So
Right.
we have a formula. I'm going to go back to the PowerPoint now. And we have this formula for resistivity.
Martin, you're on the Word document.
Am I going up and down?
No, you're on the Word document. You're not on the PowerPoint.
Oh, okay. Yeah, this is Teams is a bit of a pain in the backside. If I share content, then I have to go back to the... Can you all see that now?
Yeah.
Right. I'll go with this for the time being. If you look at the actual PowerPoint in front of you, you've got all these, as a little box I showed you, a 1mm cube is what they use to measure and get the fixed constant from. Now, what size cables do we use?
Depends on
A 1 mil cable, 1.5, 2.5, 4 mil. But obviously, we don't measure in millimetre cubes, we measure in the metre, don't we? A length of cable can be a metre long, can be 5 metres long, it can be 50 metres long to do a wiring in a house, yeah?
Yeah.
yeah.
That makes sense. So, how resistivity works, I'm not going to go through the whole rigmarole behind it, but there are set numbers. Now, I'm going to go back onto Spotlight and I'll write quite large on the board so you might be able to see me.
Marty.
Can you see me again now?
Yeah.
Right. Let me get rid of this.
Figure my asshole.
Guys, this has been recorded, so please.
Hey, who's that,
watch
bud?
it because
Never
There's
heard of
someone else in it.
I have to send these recordings into our gaffer, so if you start swearing on there, you'll just know who it is.
Martin, there's some geezer in it that we don't know.
Who?
Them ginger geese have them.
There's loads of geezers in there.
Ginger Joe.
The only ones invited are you guys, so it's the class. Plus, just to let you know, I have all your details of those who are logged on. And those who are talking, it tells me who's... So don't shoot yourselves in the foot, guys, especially because I have to be observed as well. Tony will be in the meetings as well. In the background, you won't see him. And Andy, it's the same with all lessons. You know, when they used to come into the classroom to me and sit in the background and whatever.
Yeah.
Still the same thing. So be aware, because obviously we're working from home, the monitoring us more closely to see that the students are engaging. So usually, is that okay? Right.
To do his phone.
Can you all see this now?
This ginger person ain't supposed to be in the lesson.
Fuck off, shoot.
Gentlemen,
There's someone who's not meant to be in here. He's just chatting waffle, man. I don't know. That geezer who said that thing.
Ginger Joe, fam. Ginger Joe. Let's kick him
the
out.
people in here are, you got Wakas, Mohamedou.
Stuff, man.
Now, who's Ginger Joe?
That's what I'm
Kick
saying,
it.
bro.
Geezer that we don't know.
Ginger Joe.
Trying to tear it like, but we.
So give me 1 second because I've got a Ginger Joe there.
Yeah, but how's he joined? Like, someone must have invited him. I mean,
No, it's an open session, but it's not as if it's anybody. And I will be getting.
Cannot kick him. Yeah, I think he's gone.
You've already scared him off, Martin.
No, I'm just going to find out who he is. I'll find that out later because I've got his record of where he's come and I got his email address as well.
Yeah.
So if he's changed his name, that's fine. You know, guys. So everything you do on here, it goes through our network. So anybody who's been invited onto Teams is coming through. So you got Wagcash, you got Mohamedou, Sean, Tom, Jack. So I'll just do that on the other one. Right, can you all see that on the board?
Yeah.
Yeah.
R equals row times L over A.
Yeah.
Yeah.
Right, this is the formula for resistivity. And what we're doing with this one, anybody remember off by heart what that number was, as I said, about copper? The fixed constant for copper.
No, I
It's
can't.
1.72 times 10 to the minus 8.
Good. I'm going to put
Jeez,
these are the symbols. R, measured in ohms, resistance. Rho is bent over P, which is a Greek letter rho. So it's not power, it's just it's like a bent over P, but it's a Greek letter rho. L for length. We know length is measured in meters, yeah? And A for area, and we're talking about the cross-sectional area of a conductor. So you're 1.5, 2 mil, 2.5, 4 mil. So, have you all got your calculators with you?
Yeah.
Don't find it.
Why don't you try this, guys? I'm going to put a figure in here. 1.72, 10 to the minus 8, times length, which is going to do 100 meters. And I'm going to use, give me a size of cable.
1.5.
Yeah, come over here.
1.5 millimeters squared.
Really?
Now, you can't put
No que tenga lo mío,
you can't put 1.5 millimeters squared in your calculator, can you?
No.
I would have put 1.5 or 2.5 or 4 millimeters in my calculator. I would convert millimeters back to a meter. Square meter.
10.
Times 500, isn't it? Times by 10.
Right. How many millimeters in a meter?
And
1,000. Yeah.
Yeah.
1,000. How many square millimeters in a square meter?
depends how big the square is.
1,000 times 1,000. What's 1,000 times 1,000? Anybody?
Million.
1,000,000. So a millimeter squared, or 1 millimeter squared, is 1/1,000,000th of a meter squared. How many noughts in a million?
6.
So, but we're going the other way, 1,000,000th. So instead of putting 1.5 millimeters squared, we're going to put 1.5, 10 to the minus 6. Is that okay?
Yeah.
Give me a size of cable.
1.5. 2.5.
And it's always measured in millimeters squared.
Squared.
So it's always going to be
10 to the minus 6.
Your 4 millimeter, it'll be 4, 10 to the minus 6. 6 mil, 10 mil, 25 mil, it'll always be 10 to the minus 6. We always measure cable sizes, cross-sectional area, in millimeters squared. So whenever time you see this formula, any cable size you've got is always going to be millimeters squared. So it's always going to be 10 to the
minus 6.
Brilliant. You all happy with that?
Yeah.
Yeah.
So if you can remember that number. Now, give you a quick question if you've got your calculators. Am I all right to rub this out, guys?
Yeah.
Yeah.
This is all in the book, ain't it?
This is all in the book, but it's a bit dry in the book, isn't it?
Yeah,
But
but
if you've got your calculators,
if we're writing on notepads, what's the evidence of us doing it?
you've attended here. I will be sending you question papers after tonight, after this. And once you've done the question papers, you'll send them back to me. Now, the way it's going to work, guys, is the same with all the groups, and this has been discussed across all the management meetings. I will send you work out. It must be completed by next Monday morning.
All right.
Because if you haven't sent it back to me, done it in level 3. If you haven't sent it back to me by then, I'll be putting it in the register. Because I've got to send it back to Tony. Engagement tick boxes that you haven't engaged, so you get a file even if you send it back to me late. And the reason for that is I will be sending you the answers of a Monday evening as well as next week's homework. But I must have the homework you've done before I send the answers out, because what basically. What I don't want is people just waiting for the answers on a Monday, putting the right answers and sending me back. It can't work that way. And that's what they've decided. It's just to give a bit of integrity in the actual meetings, you know what I mean? To show that you've actually done homework. You haven't just been given a question paper and then just sent out the actual answers when I give you the answers. Bit pointless. It doesn't help you anyway because you got it. You hopefully after February, if we're back by then, you will still be taking your online exam.
Do you know when
it's so much easier if you do the exam instead of having all the paperwork, but I can never guarantee it because if we close down to March and whatever, we might not have time. Does that make sense, guys?
What time does it like? Do you know if we don't go back in Feb? Does that mean that we definitely won't be doing the exams?
What it means is with the GCSEs, they're talking about what I had last year. And I'll tell you exactly what I did last year, what they asked me to do. I had to make for those who passed the exams. They passed the exams. That's fine. Don't need any evidence for that because it's an online exam. You passed the online exam. That's it, isn't it? For those who couldn't take the online exams, I had to get the workbook back off them. I had to get the homework that had been sent out back off them and put it in a folder as evidence for what we call an EV from City and Guilds who comes in. Where's the evidence to say that this student would have passed the exam? Well, this is all the work he's done. You see what I mean? It's like a portfolio to prove that you've been doing the work, not just us saying, yeah, he passed the exam, he's a good lad.
No, I'll be honest with you, Martin, that's better, you know. The exam is going to be hard because you're from online. We're not in the class, we're not even learning properly, so should just do the homework and all like that.
No, you just still go over the lessons because, again, if you've not engaged for 6 months because you've been out of college, they won't even put you for the exams. So at least with this way, this lesson now, those who are in this lesson with me will be getting the mark.
Yeah, Mom said if we fail the exam, what's going to happen then? And you just use the homework and all like that.
You'll get a homework and I'll be sending it out every week. And every week from now on, we'll be having a lesson. So I'll just be going through it, not as mad as it was before, but I'll just be going through it. When we get back, obviously, things then we'll go through what we've done already. But hopefully, and the one thing about it, guys, is if you don't do bugger all from the day we broke up before Christmas till, you know, you put March, and then I've got to put you in for exams, you're going to shoot yourself in the foot. So I need you to be doing the work for me. Again, it's not just for me. I've got to have that evidence I'll put in your folders to say that. If we say it's on teachers' discretion if you've actually going to pass the exam, I've got to show proof that you've done the work. It's like anything. You've done college, you've been at school enough years without the work to prove that you've been doing the work. How can I say that you should have passed the exam? Hopefully, it won't come to that. But I don't want you coming back after 3 months and not doing a single bit of work, and then saying, "Oh well, I'm expected to know anything," because this is what we're doing here. It's a shit. Basically, it's rubbish for all of us. But it is the way. It is what it is, and this is what everybody's having to do. I spoke to all my colleagues at other colleges, and it's the same old, same old. They're all doing the same what I'm doing. That's why we all work together and say how it's the best way to do it. That's all I can do, though. So I know it's not the best, not the most ideal, but it is what it is. Is that okay, guys?
Yeah.
Is that fair comment? Right. If you got your calculators now, if you got your iPhones, not brilliant, but you can copy this down to put, and I'll put the figures in. Resistivity, I've got 1.72 10 to the minus 8 times 100 meters divided by a 1.5 millimeters squared or 10 to the minus 6, and I'm going to get a resistance reading from that. Can you all see that I'll put on the board?
Yeah.
Don't worry too much if you can't perfect, but I'm going to show you how you put in your calculator. I want to get a resistance reading measured in ohms. So in your calculator, and just follow the steps. If I put 1.72 and then press, if you can all see that, not very good. You have the X10 button here at the bottom in the middle. If you press that, or ESP button, then press the minus button, then 8, press times, and then put 100, then press divide, and I'll put it underneath now. 1.5, press the X10 button again, minus 6 this time, and then press equals and you'll get a number. And I'll do it on mine. I'll see what we all get.
1.146 recurring.
Okay. You get 1.146 reoccurring.
Yeah.
So what does that actually mean, guys? What's that number telling you?
That is the resistance of the copper wire.
Right. When we buy cable, how long is it? What size rolls do we buy it in?
It's 100.
100 meters. So let's just say I bought a roll of cable and I wanted to make sure I'm buying 100 meters. If I got a meter, low ohm reading meter, and put it from the end of one cable to the other end of the cable, the middle bit and the outside bit, and did a resistance test, what reading should I get? What have you just worked out?
No.
What was the number you just worked out in your calculators, guys?
Resistance.
And what was the number? 1.146?
Yeah.
Yeah. So if I had a low ohm reading meter, I got my drummer cable, and where the cable's in the middle, I attached my meter there. And where the cable comes out here, I attached the other side to there. Attached it on there, a couple of crocodile clips. I should get a reading of 1.14. Let's get it right. 1.14. 1.14 ohms. And that'll be it. How many places did you go to?
3.
How many places do we work to? On the 2 decimal places.
Yeah.
So 1.14 ohms is what the resistance should be on a 100 meter roll of copper cable at 20 degrees. And if you bought that cable, what would it mean if your resistance reading was 0.97 ohms? What did that tell you about the cable you just bought?
Shit.
No, that's a lower reading, isn't it? And the best reading you can get for copper for 100 meters of 1.5 mil cable is 1.14 ohms. But you got 0.97 ohms on your meter. What does that tell you about the cable or the shop you're buying it from? Any idea?
Pure. It's not pure.
No, he's nicked it.
What, it's not like British standard?
It's not British standard, but you probably find the bloke, if you look on the back wall, he's got some 5 meter or 10 meter rolls of copper cable, and he's nicked a bit off your roll. And he's telling you, so he's telling you, he's shortchanged you. Now, you will never get that from a normal dealer, because what you normally get is 1.14 or 1.15. The resist, they always give you a little bit extra, but they'll never give you less than 100 meters. Do you know why?
Why?
They'll sue you blind. You can sue them blind. Trading standards. If you're selling a roll at 100 meters, it's got to be 100 meters there. If there's more than that, well, that's fine. But if there's less than that, then they can get sued, or they can get, you're trying to rip off your clients or your customers. You see what I mean? It's like buying a bag of sweets, 10 sweets in a bag, you only get 9 sweets. You'll not be very happy. But if you've got 11 sweets, everybody's happy, aren't they? So they'll always sell you 100 meters. And if you ever wanted to check it, that's fine. But I ain't being funny, but is anybody ever going to check that you've got 100 your rolls of cable when you buy it from the shop or get it delivered?
No.
Nah.
So what do you think we need to do this maths for then? Any idea, guys? Right.
I don't know.
In the workshop, have you been doing some testing and inspecting? Have you used the meters, anybody?
No.
Yeah.
Right. Let's say, well, actually, let's change it in. I've got a job. I've got to wire a house, and I've got to put 45 meters of cable in downstairs for the lighting. When I test it, what should my reading be? Or could I work it out?
909.
That's insulation resistance. A continuity, when you go, when you do your continuity test, you go from the to the lamp, connected together at the board.
Oh, it's got to be below.
And you test at the lamp between the switch and the earth and the R1R2 reading. Has anybody done
Yeah,
that?
it's got to be below. Yeah, it's got to be below 0.6, isn't it?
Yeah, but that's because you've only got about a metre, haven't you? Let's just think about if you've got 45 metres of 1.5 mil cable. Now, if I put that figure in, if I say I've got, what's the resistance for copper? Resistivity? 1 point. Do you remember this?
1.72.
1.72, 10 to the minus 8. And let's say I put 45 metres of cable in 1.5 mil cable. I've done the downstairs lighting circuit, yeah? And I know it's 1.5, so it's 1.5, 10 to the minus 6. If I connected the live and earth together at the board, consumer unit, and then tested at the furthest lamp, what should my reading be? Have a go at doing that in your calculator. So you put 1.72 x10 minus 8 times 45 divide 1.5 x10 minus 6. What do you get, guys? Anybody give me an answer yet?
How do you put that in your calculator again?
So you've got a calculator in front of you, put 1.72.
Yeah.
Press the
Time
X10 button or the ESP button, that X10 button, right at the bottom of the calculator in the middle.
Yeah.
So you're pressing that button there.
Yeah.
Minus 8. So you press the minus 8 times 45 and then divide. So 1.72 X10 minus 8 times 45 and then divide that by 1.5. Press the X10 button again. Minus 6 and then press the equal button. Never got an answer.
0.51.
0.51. It's got 5. I got 0.516.
Oh, yeah,
But I'm going to go to 2 decimal places and 0.51. If I tested my lighting circuit and I put 45 meters in, that's the reading I'm expecting to get it. I'm expecting to get 0.51 ohms on a meter. If it's longer, if the reading is bigger than that, what's that tell me about my actual circuit? Any ideas?
Loose connection.
Loose connection.
Loose connections, because a loose connection creates higher resistance in the circuit. But what would I use it? What would I do all this? What would the point of this?
See,
In the real world, not doing actual.
So you don't get sued. Don't get safe.
Do you remember you guys? I showed you some drawings of a plan of a building.
Yeah.
You've seen them.
Yeah.
So
Now, if you're an electrician, the first thing before you start building anything, picking up a screwdriver, you're going to have a plan of a building, and it's going to have the cable runs, telling you where to put. And I'll show you on the board. Can I rub this out, guys? You happy with that?
Yeah.
yeah.
So if I had a plan of a building, and I had a lighting point there, a lighting point there, a lighting point there, there. Say 9 lighting points. It's in a factory. There's a switch. And the cable goes from there to there, to there, to there, to there. And I was using 1.5 millimeter squared cable. And if I measured that length there, it measured 45 meters. What's my expected reading when I test at the furthest point?
0.51.
If I get a reading of 1.1 ohm, what's that tell me?
You got a loose connection.
Got a loose connection. If I get a reading of less than that, what does that tell me then? Let's say I got a reading of 0.34 instead of 0.51.
Something's not right.
Something's definitely not right. Either got been connected across there. But this resistivity, we use it for design. Now, once you've got how to work out what the resistance of a length of cable is, you can work out what your expected readings are before you even build anything. And you need to know that. Why? Why do you need to know that?
Know how much to buy.
Know how much to buy, but also when you're installing it,
You know how much cable to work.
workshop. You've had 0.1, 0.01, 0.04, 0.06. The thing about that is that's okay for a meter to a cable, but when you're working on big circuits, then it's slightly different, isn't it? You need to know what the reading would be if I put 45 meters in. Does that make sense? So when I test it and I forget 0.51 on a meter, am I happy?
Yeah.
Yeah.
Why?
Because that's what it should be.
Just get the exact right number.
Yeah, but if it's that and it's what it should be, what's it tell me about all the connections?
They're tight and secure.
That's it. Now, again, this is slightly different to what the book tells you. This is a practical application. We have to know what the resistance is per meter for every different size of cable. We don't have to remember them all. Have you all got on-site guides yet?
Yeah.
Now, when you go, and it's slightly different to what this is, but if you go to, don't do it now, you can look at it later, and I'll send you some homework where you can use it, table I1, so in index I, it gives you the resistance per meter, in milliohms per meter, for every different size of cable. Well, we use that when we design circuits. One of the other things we've got, what happens if my circuit's too big? What do you think would happen to the circuit if I've got too long a run?
So much different power.
Power loss.
You get a loss, you get voltage loss in the cables. You'll talk about this later, but you're allowed, the maximum on a power circuit is 3%. Sorry, 5%. I can't lose more than 11.5 volts. And we know we did voltage in cables. Resistors, voltage up across a load of a resistor. It comes back to that. I measure resistance reading. If I got my cable too long, too much resistance, I'll get too much voltage drop and my equipment won't work properly. So I can't have them too long. Also, what you haven't done yet, and you'll be covering on Unit 203, is the fact that I can't have my resistance readings too high because the breakers might not trip out. You haven't done any of that yet, but I need my resistance to be about a certain level. And we have what's called the maximum impedance reading. And it's on table B6 of your on-site guide. It tells you what the maximum is for. Can anybody tell me what the breaker is for a lighting circuit? What do we use? What size?
B6.
B6. And a B6 breaker, the most you're allowed to have resistance wide is 5.76 ohms or 5.67 ohms. For a ring final, what size breaker do you use for ring finals?
B13.
Not 13, that's a fuse size. 32.
That's it.
B32. The most you can have resistance wise on a ring final is 1.1 ohms. So it's quite low. So if I've got too long a run, I'll have too much resistance. And what it actually means, if I've got too much resistance, my circuit breakers won't trip in time. Now we'll come back to that later when we talk about how equipment works, breakers, the thermal side, the magnetic side of breakers in Unit 203. But if I know how much resistance I'm going to be reading when I build this circuit, because I've worked it out what the reading is, that's great. If I design my circuit and put too long a run in it, say I put 150 meters of cable and then find out my resistance reading is going to be too high, what would I do in the real world?
Cut it down.
Yeah, split it into different circuits. So instead of having one lighting circuit, maybe you have 2 or 3. The resistance is not that low. Yeah, So bring the resistance low enough. Now we'll cover that later. But for this bit, your exam questions, you will get questions on why about the actual theory, but not the reasons behind it. Now, resistivity. I'm going to move forward in your PowerPoints now. So I'll be taking. Let me lock this out the screen. Exit spotlight and go on to share content, and we'll go back onto resistivity. And in your books, guys, it's give you the answer there. I'll have to do this on that one. Can you see that? This is a typical exam question. If a cable has a resistance of 1.15 ohms per meter, while the resistance of 320 meters of the same cable. Did you see how they worked that out? On the PowerPoint.
Yeah.
So if it's 0.15 ohms per meter, all they've done then is just times it by how many meters you got. In your on-site guides on table I1, it gives you the resistance per meter for a size of cable.
Where is table? Oh, where is it? That table?
Index I in your on-site guide. You know, you got.
What page is that?
About 190, something like that. But you've got sections 1 to 11, and then you go to the index A, B, C, and it's all in the top corner. So if you scroll the top corner, you'll see appendix A, B, C, D, up to I. You've got table I1, and it gives you the milliohms per meter.
Appendix I1.
And you see that big table there? And it starts off with copper.
Wait, hold on, I got table 11, table 12.
No, it's table I1. It's not table 11, because it's index I, isn't it?
All right.
Yeah, it's an I1 and then an I2. And the table I1, because like all the other tables are from the index, so B6 or E5, they're all from whichever part of the index. To make it easy if you're looking for it. So table I1, in fact, can you tell me what it is for 2.5 mil? You have 4 boxes.
I can't find. I don't know where. I'm in the appendix, but that's.
You got A, B, C, D, E, F, G, H, I. It's towards the back of the book.
Yeah, I'm on it. Page 195.
And it's got table I1, a big box down the side.
Mine's just got table 11, table 12, and table 13.
It's table I1. This is your on-site guide.
Oh yeah, I got it.
Yeah, you got it. It's table I1, and if you look down there, you've got 1 mil, and 1 and 1, 1 plus 1, and you got 1.5, 1.5, 1.5 plus 1, 1.5, and 1.5. Then you got 2.5, and so on. What's the option number you use for this 2.5 on its own?
7.41.
7.41, but it's milliohms per meter. How do I convert milli back into ohms?
Times it by something.
Times it by or divide it?
Someone help me out.
I thought, oh, what?
Well, it's either one or the other, isn't it?
Times it?
Divide.
Okay.
The reason being, it's milliohms per meter. What would that be as ohms? Which way would the decimal point go? To the left or the right?
Left.
To the left.
To the left. 3 places. So I'll go back to there. 0.000741 to make it ohms per meter. Now, the reason it's milliohms per meter in the book is just so you don't have these stupid numbers. All these numbers. If you look at when it goes down the book and the cables get bigger, the numbers get smaller. So you don't make a mistake. All they've done is turned it into milliohms, move the decimal place 3 places to the right, and then you got 7.41. And it's just the fact that they remember the on-site guide assumes that you already know what you're doing. You already know what this is all about. It's not designed for students, it's designed for electricians on the site. So it's expected to know this, but it's done it in milliohms. And once you've done any maths with that, in fact, if I got 100 meters of 2.5 mil cable, and if it's 7.41 meters per ohm per meter, what would 100 meters it be? If I'm using a low ohm reading meter, 100 meter roll of cable, 2.5. What would 100 meters be? Using that number.
About 250.
100.
Well, if I'm times this by 100, how many places do I move decimal points?
3. 2.
2 to the right.
So
So
741.
But it's milliohms per meter. So to get the rid of the milli, what do I do?
Sounds about right.
3 places to the left. So I go 1, 2, 3.
So 0.741.
0.74 is what you'd read on your meter if you was testing a 100 meter roll of cable, or you just put 100 meters in of 2.5 mil cable. You should get 0.74 ohms on your meter, and then you know your connections are good if you've used 100 meters. If I use 50 meters, what should the reading be?
Half of that.
If you use, sorry, what?
50 meters.
We times it by 50.
Yeah, and that's what you do. The on-site guide is designed for you on site. So if I go back to the formula, I'm going to rub this out. 50 meters would be 0.36, but when I do this formula resistivity, in the on-site guide, it's already put these two together, but it just uses as 1 meter. And it already gives you the actual size of cable. So all you have to do using the on-site guide is times it by however long your run is. And when you've got drawings in front of you and you're designing these circuits, you want to know what the resistance reading will be when I do a test it. Do you know what I mean? I want to know if I put this 100 meters in, what should the reading be when I test it? If it's higher than that, what's it tell me?
Not right.
There's something wrong, loose connections. If it's lower than that, I've got some serious problems. But it starts from this formula. But the problem we got in your exam, what do we have to do? They can ask you about this formula. So I'm going to go back to the PowerPoint and go through a few questions on the PowerPoint. Is that okay, guys?
Yeah.
Where's the PowerPoint?
If a 50 meter length of conductor has a resistance of 0.1 ohms, what would the resistance of 500 meters of sand cable? Can you see that?
Mm-hmm.
Actually, let's do this slideshow. On current slide. Can you see that now? Can you still see that?
Yeah.
So do like that. So if cable, take it.
It's the next one.
There you
That
go.
one.
That better?
Yeah.
Right. You can see on there, 50 meters of conductor has 0.1 ohms. What would the resistance of 500 meters be? What are you doing on that? What are they doing there?
Dividing.
Yeah, they're getting a ratio, aren't they? So how many times does 50 go into 500?
10.
So your original reading was 0.1 ohms. What they've done to the 0.1? Times it by?
10.
That's it. So it's what you're doing, increasing it. Now if you look at this one, a conductor has 750 meters, a resistance of 0.013. What are the resistance? Are these questions in your book blanked?
Nah, they're all filled out.
They're all filled out. That's why I'm going to bother with this. So those who have filled out in your book, what I will be doing later, guys, is sending you a question sheet out that's not in your book, and you can have a go at working out. Is that okay? And then you're going to send that back to me by next Monday, and I'll be putting that in a digital folder. So when I do get back into class, I'll be able to print them off at college and put them in your real folder. And then there's the evidence.
Can we
Are you sending us this on email?
Yeah, you can. You said you will send it back to me via email. I'm not allowed back into the college. I'm only allowed in for a certain time, but it's on it's on shutdown. I'm allowed to go in for a couple of hours on a Thursday. That's it. And I have to get permission and get it all authorised. So what I will be doing is you sending me stuff, and I'll be saving it in a digital folder for you. The one thing I do
So,
need
you
to
know,
do, yeah. So
you
I'll
know
just
when
say-
we send you, you know when we send you work on email, yeah, the homework. Would you like? Can you reply saying that you got it? Because sometimes you just don't reply at all. Like,
Yeah.
I don't know if like you've got it or not. So
Well, I would do. I'll be
Trust
replying
me,
on
you want
Friday.
man of black school.
Well, I'll be doing that. I'll reply on the Friday, and I'll be asking people who haven't sent me the work yet. Don't forget to finish your homework off. But I'll reply fine. Once I get the email, I'll be just sending you an email back. Okay. The problem I got with the emails, guys, and just be aware of this. When I send you an email, because I'm working from home, is the fact that I've only got restricted access to the systems at college, so I can't go into your personal emails. I have to use what's called a program called Pro Monitor. And Pro Monitor then, for me, only gives me access to your BMET emails. Does that make sense? So what I can't do is actually...
Yeah, that's what I'm talking about. Like, even on the...
I can't do it to your personal emails. You have to log into you have to log into emails. The only thing I can send you is a text. So what I will do is send you a text, because that goes straight to your phone number. But to me, send any work out or do any work for you, email-wise, it goes straight to your BMC email.
The Outlook.
Yeah, it's the Outlook email, but BMC number. It doesn't do it to your personal emails, as far as I'm aware. So you have to log in via that and look at your BMC. It's all your own personal space. You know, you did it at college, and you did it set you up on the top when we was on the mezzanine floor in the LRC. You had MyMet.
Yeah.
Yeah, and you can log onto there. You have your own personal emails. Now, what I would do is when you send me stuff, save it yourself. Don't just delete it. And when I send it, I will then, when I get a chance to go back into college, I'll be printing them all off, and then I'll be putting them in your folder. And that's the evidence that you've done work, not just filled in a book with all the answers. And that's what they're looking for, you know, genuine work, to make it authentic, basically. But you need to email me, and I'll let you know by the Friday who hasn't sent me the work in. Now, if you've forgotten about it, hopefully you won't, because tonight I'll be sending you the workout. It's not going to be 4 hours, 5 hours of your time. It's going to be a couple of hours. You can do it over a couple of days. But once you've emailed it back to me, email it me, and then I'll reply back saying, yeah, great, okay. Those are what don't get, I'll remind you on the Friday. But if I don't get it by the Monday, this is the policy now. Don't get it by the Monday, I'll say that your work hasn't been done. And that's when Tony starts emailing you or your mum and dad's, which is a bit of a pain. Does that make sense?
Yeah.
That's the only way I can do it, because that's what it is. It's just a case of we've got our evidence, and they're tracking us and tracking you to make sure that you're, because it's Microsoft's Teams is through the college websites, so they know who's been on and who's doing what and all the rest of it. So it is what it is. Is that okay, guys? So it's not major homework, but I'll be sending it. It'll be set every week after the sessions. Right. Back onto the PowerPoint. Anybody questions before we carry on? Yeah.
That's a no.
Right, then I'll go back onto the PowerPoint, resistivity PowerPoint. The research of the cross-section area, you see this formula here?
Yeah.
Don't bother. I've never seen that question asked, because we're not doing that yet. That's series and like a parallel circuit, isn't it? We're not doing that. They don't ask you questions about that. What they do ask you about is the actual area of a conductor using this formula on the board, R equals rho times L over I. Now, these questions here, I'll be sending some questions down here. Can you see the PowerPoint now?
Yeah.
Now, this is wrong. Can anybody tell me what's wrong with this?
It's to
it's missing the cube at the end.
It's not cube, it's got 10 to the minus 9, it's 10 to the minus 8.
Oh, I couldn't see that.
Yeah, you see on the actual PowerPoint, it's got 10 to the minus 9. I think that's a typo by them, but these are the main ones we use. We use copper for your normal wiring, household wiring and small circuits, aluminium for the big circuits, and we're talking 60 mil, this is industrial. Silver, they use that, it's not as good as copper, but it doesn't tarnish as much. They use it, but it's electronics. Gold, you've all got phones, so you'll find that when people say you send your old phones back and they strip them down, there's gold, because gold is not as good as copper. Does anybody know why they use gold in electronics?
Is it rough?
Bombs.
What's that?
Do they use it in
It
bombs?
doesn't rust.
You got gold in your phones.
Oh.
It doesn't rust. It
The
don't.
reason they use gold, and they used it on the actual atomic bombs, is because it doesn't rust. And whoever said that, brilliant, well done.
Still.
It doesn't rust, it doesn't tarnish. You can leave it in a cupboard for 20 years and it will still be perfectly nice and shiny. It didn't go, you don't get a tarnish. Silver is not as good as gold because that does get a tarnish. You have to polish silver. Copper, if you leave it exposed, it will go green, as you may have seen. It rusts, oxidizes, basically rusts. So does aluminium. Brass is a mixture of copper and tin, and you've got two types. One is for connections. We use them in your connections in your actual back of your sockets and your switches and whatever. And again, terminal blocks as well. We use brass in terminal blocks as well. So depending what you need the brass for, one is slightly harder than the other. Bigger connections use bigger cables need the stronger brass. Yeah. The smaller stuff we use is a smaller, cheaper brass. Now, can you all see this PowerPoint there? The R equals rho times L over I.
Yeah.
Yeah, and this is the formula we're doing, but again, resistivity times length of the cross-sectional area, R equals rho times L. Again, that's a Greek letter, it's a slightly bent over P. But obviously somebody at Sitting Guilds doesn't know how to do the actual logos in properly, but that's fine, or the symbols properly. It gives you a list of all there. Again, rho times length divided by the area. As you can see, 1.72, and it's not to the -9, it's to the -8, and you get a correction. Is that okay? Now, this is all in your book as well, isn't it? And you've got examples there.
I thought it was to the -6 from the cable size.
The cable size is 10 to the -6. When you're talking about 1.5, 2.5, because it's cross-sectional area of there. But the resistivity, if I can go back to that table, it's a fixed constant. So for copper, it's a fixed constant for copper. It's a fixed constant for aluminium, silver, gold. So whichever material you're using, instead of being, and I'll go back to the screen.
Martin, do you know how it's got 10 to the -9 there? Are we supposed to change ours to 10 to the -9 on there?
No, 10 to the -8.
Oh, okay, so.
I can tell you now, it doesn't work out if you use 10 to the -9. The reading's not. It's a mistake on the PowerPoint. I'll change that, but the point is, it's a mistake on the PowerPoint that they've got it wrong. So I'll put you back on spotlight me. Because I can tell you now, if you do measure it, this is the formula we're using, and this is what they use. The rho, like a bent over P times L, and that's always for copper, the fixed constant 1.72 10 to the -8. If you try 9 with that one, your readings will be ridiculously stupid or too high when you do the equation. So I've already been through this before, and that's what it is. They've made a mistake on the PowerPoint, so please ignore that. In your books, is it 10 to the -9 or 10 to the -8?
10 to the -8.
Yeah, you stick with it's just a glitch on the PowerPoint. I'll get that sorted out. So 1.72, 10 to the -8. The one thing before I go off with this, guys, is if you see this formula there, they may
Martin, big screen, so.
Pardon?
Put yourself on a big screen. Like, you're not half.
Yes. You gotta click on his name. Click on the thing.
Click on me. Can you see me on the full screen now?
No, I can see retrosivity, bro.
Okay, let me.
Yeah, that's better. Yeah.
Got me now?
Yeah,
Okay.
Yeah.
It was just sharing between one side and the other. Can you see that now?
Yeah.
Right. What it is with this formula here, they ask you to work out the resistance of a length of cable. Where was that?
Oh dear.
It swung away if you might.
Something strange. I'll have to block part of you guys. I'll set up the settings afterwards. Right. On this one here, guys, this is your formula. Yeah. Resistivity, rho times L over I.
Who's this?
I'm waiting for you, Martin.
Yeah, it's just a couple of idiots. I'll find out who they are. Because once they log on to there, they got the email address.
Stop now.
Well, again, kid being idiots. These kid being idiots. I'll just send that up to Tony. So whoever's playing silly buggers, I'm sure he'll have a chat with the parents.
Tony would come to their house.
I'll send Tony round.
Big Tone. Big Tone's gonna come.
You know what Tony's for. Right, guys, with this, There's a couple of things that they won't ever ask you to work out. They'll never ask you to work out this row. You know, we've done transposing formulas.
Yeah.
Yeah. So they're never going to ask you to work out what does rho equal because it's a fixed constant. It's like gravity. It's a set in stone. It doesn't have to work out there. What they may ask you to do is work out if they give you resistance reading and they say it's in copper. And how would you get it? Say if I had, say, 50 meters of 1.5 millimeter cable. How would I work out? Actually, no, let's do it this way. Not 50 meters. Let's say I had a resistance reading of 0.6. Can you all see that, guys? I'll do it bigger. Can you all see that? 0.6 ohms. And the cable itself is 1.5 meters, 1.5 millimeters squared.
Nah, they're taking the piss. Whoever's that is, they're taking the piss, bro. I'll be honest with you.
Martin and mocking you.
They're saying Martin is don't even want to say that word, to be honest with you.
Pete.
Oh well, but you got arseholes, haven't you? If they're arseholes, they're arseholes, so don't worry about that. Because kids are, you know, when they grow up, get past the age of 10, they might act like they're adults. But what I'll do, I'm going to stop it. So next week, it's only you guys can come in. I'll do it after this. I'll change all the settings on this, so you're only allowed in. Anybody else who tries to join the group, they'll be blocked out. But I'll also send the tracking monitor to our IT, and the IT will then obviously block them or put them on a warning. It's the usual. It could be one of our lads just change the name on their profile. But when you log in, all your other details are there as well. Maybe they don't realise that.
It's probably no filter gang, I'll be honest with you. Them and a real,
It's
so.
Just with them out here.
Yeah, them and a real.
Oh, can I just do one?
Sure.
Well, don't worry about them.
Brought the coffee shop.
You lobby.
Telling me that.
He's denied. There you go. You still see me?
Yeah.
Yeah, fine.
Yeah.
And there you go. Fine. Right. If I got 0.6 ohms, 1.5 millimeters squared, how would I work out the length?
Times the ohms by the.
How would I transpose this?
So the P goes over the other side where the R is, and the R replaces where the P's.
Well, not when remember the R's in the middle, so what's it regarded as being the number on top?
Yeah.
So if I do it like this, so the R's there, I'll put a line.
P.
This row go to the top to the bottom, yeah? So I'll move that from there to there. Where's the A go?
Over the other side, so it's times.
So it'll be 1.5 10 to the minus 8 times 0.6 divided by 1.72. So you have 1.5 10 to the minus 8 times your 0.6 divided by 1.72 10 to the minus 8.
Is that number constant with that side of the bit?
It's constant. I'll never ask you to work it out. It's set in stone. Is that okay?
Yeah.
This is what they'll ask you to do. If you can transpose it, is any problem for you transposing that? They're happy with that, how to transpose it.
No, that's fine.
Yeah. So they'll ask you to do that, and then you just put that in your calculator. Anybody got an idea what the answer would be? In your calculator, put 1.5, do the x10 minus 6, because it's the cross-sectional area, times 0.6, and then divide that by 1.72 x10 minus 8, and that equals. Then we got
52.32.
What'd you get?
52.32.
So 1.5. So 1.5 x10 minus 6 times 0.6 divide 1.72 x10 minus 8 equals. Did anybody get 5.23 10 to the power 13? We'll get a funny answer.
No, I just got 52.32.
52.32 is the correct answer because that's what it should be for that type of resistance reading. If you're getting a funny answer, you may have to put the top bit in brackets. So I'll put that in brackets. As mine's coming up 50.2. Yeah, so 52.3 meters. So you've worked out the length. Is that okay, guys?
Yeah.
Now, I'll be sending you some questions out later to have a go at, and I'll give you I'll send you an example as well. So I'll rub that off a second. And again, hopefully, some of you will get this question where it says if resistivity equals rho times L over A, make A the subject. How would you make A the subject?
A goes over the other side, so it becomes R times A.
On the bottom. Sometimes it's not a bit like some of the power formula questions. They ask you just to transpose it, don't ask you to do any working out. If you get that, brilliant, because you're all happy with transposition, aren't you?
Yeah.
Yeah. So with resistivity, go back over the main points again. Resistivity is talking about every material's got its own fixed value. There's a value of, for copper, 1.72 10 to the minus 8, for aluminium, and they are set in stone, don't change. Can anybody tell me why we need to know this? Can you remind?
So we know how long our cable is going to be.
Yeah, so when you install cables, and if you've got a drawing that says you've got to put 35 metres of 10 mil cable in, when you test it, you know what your expected readings are going to be. Because you look at a drawing, I've got 25 metres of this 4 mil cable. When I install that, I know what the readings are because I've just worked it out on paper, because I'm now an electrician doing design as well, which you will do. And when I go and build it and test it, I tested the readings I've got is what I've worked out them to be. I'm happy with the circuit, aren't I? If they're not what I expected them to be, what does that tell me about the actual circuits I'm building?
Something's wrong.
Something's wrong. If you look at a drawing, and maybe when you get a job on site, you're testing somebody else's work, and they've got a drawing, and they're telling you the drawing they've put in, what you will do on site is get an actual drawing and run on your drawing your cable routes. And if they've done that, and you're testing their work, and their readings are not what you've worked out, it can take you a couple of minutes to do this, and you will do it on site, trust me on that one. When you're working with drawings on site, and you know your cable runs, you will work them out before you install them, or if you're testing them, you'll work out what you should be getting when you go and test it, and if it's not what you expected to get, then you know there's a problem with the job. Does that make sense?
Yeah.
Because you are, if you think about the houses you're in now, you're not doing anything like the stuff you do in the actual boards in your workshop. Your lighting circuit's going to be about 30 or 40 metre run. Your sockets are going to be 30 or 40 metre runs, depending. And every house you've got is probably different. So not one size fits all. If you've got a large one, a short, 3-bedroom house, a mansion, a 1-bedroom flat, the runs are going to be different sizes. But you need to know what those readings are going to be before you've actually built it. And then you're just checking to make sure when I've built it, yeah, that I'm testing it. I've got my lighting circuit. I've tested that, or I've got my ring final, I've tested that, and the readings are what I expect them to be. What's that tell me about my job in a couple of different ways? It tells me what? If I get the readings, all the readings I've worked out, when I test it, I get those readings. What's that tell me about the actual circuits themselves?
They're all good.
Yeah. And if I've got these readings and they comply with what's in the regs, I'm complying with regulations as well. I'm ticking boxes without even realising it. Now, this is the awkward bit about this, because in a classroom, I would show you circuit drawings, and I'd show you getting to work it out, but I'll be sending you this as homework tonight, yeah? And you can have a look at them, and I'll send you some drawings, and you can have a look at a cable run. It goes into what's going to be in Unit 203, and if I say that cable run's that long using 2.5 mil cable, you can answer the question, how long what's the expected reading for that circuit? Does that make sense?
We'd use that.
Yeah, so I'll send you that, and it's going to be a bit easier when you see it in front of you. Anybody got any questions, guys?
Well, use that formula behind you to work that out.
Yeah. And do you remember? And I'll send you the paperwork, and I'll show you how to put it in on your calculator as well. If some of you have got issues reading that whiteboard, yeah. So I'll send it on a piece of paper, so it's more simple, and I'll put it in the boxes, and which if it's in a square box like that, the X10 button, that's the button you press on the calculator. Some of you have got X10 buttons, some of you have got EXP, exponential, same thing. So I'll send you that as well. Any questions, guys, at the moment?
That's it.
Right, there is some questions in your book, and if those who haven't done it yet, can you go back over your book, use it as revision, and get your questions in your books and start filling your books out. If we can't take the exams, that's going to be my evidence for you to say, yes, he did the work, and he should be given the grade for his level 2 science, yeah?
Yeah, no worries.
Is that okay? So, if that's the case, do all that. I can, when we could get them back in, it might be even a case if you can't go back into college. What we did last year, the students had to drop the books off at the reception. We had to put them in storage for a couple of days with the virus, and then we put them in the folders, and they didn't come back into college. Not until the summer, and they was just doing the practical health and safety, which is a mandatory unit. Yeah?
So, Martin, we're finished now.
We're going to be finished now, guys. Any questions before I go?
Do you know what's his name? What's the other teacher that does our health and safety?
Wayne? Or was it Ian?
Ian. Nah, Ian. I haven't heard anything about him. Are we still doing stuff with him? Or
Yeah, I'll be having a chat with Ian later on today, and I'll be asking what he wants me to do. Did you pass your exams? You ready for the exams?
We didn't do our exam.
Yeah, I'll find out. I'll be having a chat with him. We have a team meeting as well. We do it via Teams. I'll be discussing what's going on.
Had lessons.
Yeah, I know, but you might be having lessons with Ian as well via Teams. If not, he can't do that. I'll be doing it. We'll do it anyway. Either way, you'll get the work anyway. Is that right, guys?
Tomorrow?
Yeah.
What time we got it tomorrow?
Same time tomorrow. Then I'll be moving on to the next sheet because again, your homework will cover today's session and tomorrow's session as well. And the next one we're doing tomorrow, so you can read up in your books if you want to.
Right,
is connection of meters, and I will show you that.
You're going to send us homework on Teams now after this?
Pardon?
You're going to send us homework on Teams now?
No, I'll be sending you via email because, again, through Teams, I know some of you have got issues with this. So I'll send you an email to your email address, but it's going to be your BMET email address.
Are you going to send it after this lesson?
Yeah, it'll be, well, tonight, because I'm going to put some questions together, put a few grids in there and give you a bit more information.
Oh, no.
Yeah, and then I'll put what I'll add to that is how to do it on the calculator, because again, one or two, again, it's been a while since you use those calculators to what we need for the exam. So I'll put that together for you. I'll send it out tonight, and then you can actually have a go.
Will we be able to like type on the document that you sent?
It'll be a Word document.
What? So you can type it on your phone, yeah?
Yeah.
Yeah. So I'll send you to as a Word document. You fill them in and send me the completed. Do me a favour, guys. On your Word documents and all that, I need you to put your BMC number and your name on it. Because when I take them into college and print them off, then it will go into your folder. Because I'll just be saving them in one big folder, printing them all off in one time. If you don't have your name on it, I won't know who it is. So just type in your name and type in your BMC number. And just, you can put that, for those who not use Word so much, you can put that as your header. Your name and your BMC number. And then every page you ever do on the documents, it'll always be the same. Is that okay, guys?
Yeah, that's fine.
Any other questions?
No, that's it. Sweet, Martin.
Right.
That's about that.
I'll see you tomorrow. It'll be about. Yeah, I'll see you tomorrow. Mate, it's going to be 1:30 tomorrow.
All right, Martin.
I've got a meeting with Tony beforehand. I want to see what's going on today.
Bless or respect.
That was a good day, lad.
Yeah, we're happy with that, guys, so far.
Sweet. Yeah, sweet.
All right, guys. You look after yourselves, and I'll see you tomorrow.
Yeah,
one thing. You know, you can talk to each other by teams. Nearly there. You know, you can talk to each other by teams. If you've got the homework, if you want to work together, give yourself a team's call. Instead of being sitting there by yourself.
I'll shout at you, man.
Yeah, Thomas, shout me, or Dylan, shout me.
Oh, you're what? I'll shout at you, babe.
Talk a little bit quieter, but you can join your own little groups, yeah?
Yeah.
All right then, guys. Have a good one, and I'll see you tomorrow. I'll see you tomorrow, okay?
Nice.
Yeah, no worries.
Sweet.
In a bit.
Nice.
Be good. Be safe. Take it easy.